Hello viewers, welcome to my channel. I'm Hasham. So now I'm continuing the problems on correlation analysis. Last video, 3 problems I have completed. I have explained you how to compute the Carl Pearson's coefficient of correlation. But the last 3 problems where the same formula is applied because the deviations are taken from actual mean. But now in this video, I am going to explain you the problems where deviations are taken from assumed mean and the formula will get changed. So directly by seeing the problem, we cannot know whether we should take the deviation from actual mean or assumed mean. Only after calculating the mean value, then we have to decide whether actual mean or assumed mean should be taken. That's what I'm going to explain you. So my suggestion to all my viewers, genuine viewers who are really interested in gaining the knowledge, in getting the command on the subject of statistics, watch the video in sequence. Don't join in between right now without watching the first video on theory, without watching the first video of problems. So keep a rhythm that after for theory video, you must watch the first video, then second video. Like that, definitely you will get a lot of command on the subject. So I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Take a screenshot of these 3 problems, then I'll explain. Come on. Now see the 4th problem. From the following data, compute Carl Pearson's coefficient of correlation. X values are given 6, 2, 10, 4, 8. Y values are given 9, 11, 6, 8, 7. Arithmetic means of X and Y series are 6 and 8 respectively. This is a new point in this problem. In the problem itself, it is given the mean should be taken as 6 for X series and 8 for Y series. That means these are the assumed mean. Specifically given in the problem. We have not calculated. In the problem itself it is given. So it is the assumed mean. So see here. Calculation of Carl Pearson's coefficient of correlation. X values and Y values are given in the problem. Same to same I have taken. The total of X is 30. Total of Y is 41. Now calculate and see the mean. X bar is equal to summation X by N. 30 divided by 5, 6. So X bar, mean of X series is 6. Mean of Y series, summation Y by N, 41 by 5, 8.2. This is a new point, first time we are coming across. The actual mean is in fraction. Earlier 3 problems we have done. All the 3 problems, whole number was there. This is the first case we are having fraction. So whenever fractional value is given, it is better to take the deviations from assumed mean. From assumed mean. In this problem, assumed mean already given in the problem. Treat X series 6 and Y series 8. Right? Now the columns require are dx. Remember, earlier previous 3 problems we have taken only X. But here we are taking dx to differentiate that X will be applied when deviations are taken from actual mean. And this dx will be applied when deviations are taken from assumed mean. So here x minus a. X values are here and a assumed mean is given in the problem. 6 is the assumed mean. Now 6 minus 6, 0. 2 minus 6 minus 4. 10 minus 6, 4. 4 minus 6 minus 2. 8 minus 6, 2. Take the total of dx, you are getting 0. We are getting 0. Now dy is equal to y minus a. A is 8 given in the problem. The mean of Y series is 8 given in the problem. So y minus 8, 9 minus 8, 1, 11 minus 8, 3, 6 minus 8, minus 2, 8 minus 8, 0, 7 minus 8, minus 1. If you take the total of dy, you are getting plus 1. Remember, when we take the deviations from actual mean, summation x 0, summation y always 0. Both x and y will be 0 when we take the deviations from actual mean. But when we take the deviations from assumed mean, you may get 0 or you may not get to 0. So here summation dx we are getting 0. Summation dy we are not getting 0, we are getting 1. Remember this point. Now dx square, now square these values. 0 square 0, 4 square 16, 4 square 16, 2 square 4, 2 square 4. Minus into minus will become plus. Now dx square is 40. dy square, 1 square 1, 3 square 9, 2 square 4, 0 square 0, 1 square 1. Take the total of summation dy square 15. dx into dy. Multiply these two columns. 0 into 1, 0. 4 into 3, 12. Minus into plus will become minus. Minus into plus will become minus. Remember, don't commit the mistake. I cannot help in calculating mistakes. It depends on you. Calculator is before you. Don't commit any mistake. So minus into plus will become minus. 4 3 is 12. Plus into minus again will become minus. 4 2 is 8. 2 into 0 is 0. So 2 into minus 1 is minus 2. Take the total, you will get minus 22. We got all the values. Now remember the formula. The formula will get changed. Carl Pearson's correlation coefficient. R is equal to summation dx dy minus summation dx into summation dy by n. This is the numerator. Denominator, summation dx square minus summation dx whole square by n. Summation dx whole square by n. Similarly, summation dy square minus summation dy whole square by n under root. This is the formula which is applied when deviations are taken from assumed mean. In the last video, we have taken the deviations from actual mean. The formula was very small. Here the formula is a bigger one. Now R is equal to summation dx dy. How much is summation dx dy? Minus 22. Substitute the value. Summation dx dy minus summation dx into summation dy. Here we have summation dx is 0. Summation dy is 1. So 0 into 1 divided by n. N is 5. 5 items are there. Numerator completed. Denominator summation dx square. Here summation dx square 40. I have taken 40. Minus summation dx whole square. Summation dx whole square. How much is summation dx? 0. So 0 whole square divided by 5. 0 whole square divided by 5 will become 0 only. Then summation dy square is 15. Minus summation dy whole square by n. Summation dy is 1. So 1 whole square divided by 5. Now simplify. Minus 22. 0 into 1 divided by 5 is 0 only. When you multiply anything with 0, you will get 0. So this whole thing will become 0. So numerator will be minus 22. Denominator 40 minus 0 whole square by 5. Again you will get 0. So 40 under root. Here 15 minus 1 whole square by 5. 1 square means 1 only. So 1 divided by 5 is 0.2. So here 15 minus 0.2. So numerator minus 22, denominator root 40, 15 minus 0.2 is 14.8. 14.8 under root. Now 40 under root. If you press under root 40, you will get 6.3246. Then 14.8 under root, you will get 3.847. Now minus 22 divided by, multiply these two terms, you will get 24.3307. Now divide 22 divided by 24.3307, you will get 0.90 minus. Numerator you are having negative figure. That means correlation coefficient is negative. There is negative correlation between x values and y values. Both are moving in the opposite direction. That is the meaning. Over. So this is the fourth problem. Now I am reading out the fifth problem. Fifth problem. Calculate coefficient of correlation from the following data. X values are 100, 200, 300, 400, 500, 600, 700. The values are large values. If you take these values, the calculation will be more because the values are more. Similarly, Y series are 30, 50, 60, 80, 100, 110, 130. We can take the same values and calculate correlation. But if you want to reduce your time, if you want to reduce your effort, divide all x values by 100 because two zeros are common. Two zeros are common in x series. So to remove two zeros, divide by 100. All the x values will be divided by 100. So you will get 1, 2, 3, 4, 5, 6, 7. We have simplified the values. Instead of taking 100, 200, 300, 400, now I am taking 1, 2, 3, 4, 5, 6, 7. Now see here, ultimate the value of r will not get affected. The r value will be same. Whether you take the same values or you take the reduced values, r value will remain same. So why we take all these bigger values? We'll simplify it. Why we can simplify? Because one of the property of correlation is it is independent of change in origin and change in scale. Even if we divide all the values by a constant, the value of r will not get affected. That is the property of correlation. Secondly, y series 30, 50, 60. So 1 0 we can omit. So divided by 10. So y series will be divided by 10. So it will become 3, 5, 6, 8, 10, 11, 13. So to simplify our calculations, to reduce our effort, we can do this. Otherwise, if you have much time, if you have lot of time available, then you can take the same values. The values will be larger and it will take more time to calculate. Ultimate answer will be same. This is a new point in this problem. Calculation of Karl Pearsons. Here, to simplify the calculations, we divide the series x by 100 and series by y by 10. Since correlation coefficient is independent of origin and scale, again I have written the property. Why I am doing this? Because correlation coefficient is independent of change in scale and change in origin. Now x values are 1, 2, 3, 4, 5, 6, 7. In the problem it is given 100, 200, 300. I have removed two zeros. Take this. Second, y series it is given 30, 50, 60. I have removed 1 0 and I have taken 3, 5, 7, 8, 10, 11, 13. Now we don't know whether deviations should be taken from actual mean or assumed mean. So we have to see the mean. If we are getting whole number, take the deviations from actual mean. If we are getting in fractions, take the deviations from assumed mean. That's it. So we'll calculate the mean first. X bar is equal to summation x by n. Summation x 28. 28 by 7, 4. And y bar is equal to summation y by n. 56 divided by 7. You will get 8. So we got both the means in whole number. So we can take the deviations from actual mean. Simple formula will be applied. Summation xy by summation x square into summation y square under root. See, compare this formula and this formula. This formula will be applied when deviations are taken from assumed mean. And this formula will be taken when deviations are taken from actual mean. If the mean is in whole number, then deviations from actual mean. If the mean is in fraction, take the deviations from assumed mean. That's it. Now, small x is equal to capital X minus x bar. X bar, how much we got? 4. So x minus 4, 1 minus 4 minus 3, 2 minus 4 minus 2, 3 minus 4 minus 1. Then 4 minus 4, 0, 5 minus 4, 1, 6 minus 4, 2, 7 minus 4, 3. Take the total, you must get to 0. You must. If you are not getting 0, that means your calculations are wrong. So check it yourself now itself. Now summation x 0. Summation y. Y minus y bar. So y bar is 8. So 3 minus 8 minus 5. 5 minus 8 minus 3. 6 minus 8 minus 2. 8 minus 8 0. 10 minus 8 2. 11 minus 8 3. 13 minus 8 5. Take the total and check it. You must get 0. Now square. 3 square 9, 2 square 4, 1 square 1, 0 square 0, 1 square 1, 2 square 4, 3 square 9. Take the total 28. Y square 5 square 25, 3 square 9, 2 square 4, 0, 2 square 4, 3 square 9, 5 square 25. Take the total 76. X square we got, y square we got. Now x into y. Multiply x into y. 5 into 3, 15. 2 into 3, 6. 1 into 2, 2. 0 into 0, 1 into 2, 2, 2 into 3, 6, 3 into 5, 15. Remember, minus into minus will become plus. Take the total 46. Now Karl Pearson's coefficient of correlation are summation xy by summation x square into summation y square. Xy is 46. X square 28 into 56 under root. So 2128 root, it will become 46.13. So finally answer is plus 0.997. There is a high degree of positive correlation because the maximum value of correlation is plus 1. Maximum, it will never exceed plus 1. It is very near to plus 1, 0.997. So there is a high degree of positive correlation between x and y. That's it. Next problem. 7th one. Calculate Karl Pearson's correlation coefficient from the following data. X values are given, y values are given. So we don't know whether we can take the deviations from actual mean or assumed mean. First we have to calculate the mean and see whether it is in whole number or in fraction. If it is in whole number, take the deviations from actual mean. If it is in fraction, take the deviations from assumed mean. Now, calculation of Karl Pearson's. X values are given, y values are given. Don't make all these columns. After finding out the mean value, we decide what are the columns we require. So first x column, whatever is given in the problem, y, same values are given. Summation x 226, summation y 169. Now x bar is equal to summation x by n. 226 divided by 8, 28.25. The mean is in fraction. So we have to take the deviations from assumed mean. This formula will not do. This formula we have to apply for assumed mean. Right? Similarly, y bar is equal to summation y by n 169 by 8, 21.125. So both the actual mean values are in fraction. Now let the assumed mean of x be 29. Actually we got 28.25. So any value we can assume which should be nearest to 28.25. We can assume anything. So x values are 25, 18, all these are the values. You can take the assumed mean as 25. You can take the assumed mean as 18. Anything you can take. But if the assumed mean is very near to actual mean, your calculations will get reduced. Your time will be reduced. That is the reason why I have taken 29 as the assumed mean of x. And y 21.125, I have taken assumed mean as 20. 20 is very near to 21.12. You can take 21 also. But I have taken 20. That's it. That means answer will be same. Now, dx. We will open x column if deviations are taken from actual mean. If we take the deviations from assumed mean, we will take dx. So dx is equal to x minus a. A stands for assumed mean. What is the assumed mean of x here? 29. So x minus 29. 25 minus 29 minus 4. 18 minus 29 minus 11. 32 minus 29 3. 21 minus 29 minus 8. 35 minus 29 6. Like that I have taken deviations. Total is minus 6. Summation dx is minus 6. Now dy. Y minus a. What is the assumed mean here? 20. So y minus 20, 16 minus 20 minus 4, 11 minus 20 minus 9, 20 minus 20 0, 15 minus 20 minus 5. Like that you have calculated summation dy 9. Now square dx square, this one we have to square. 4 square 16, 11 square 11 into 11 121, 3 3 is a 9, 8 8 is a 64, 6 6 is a 36, 0 3 3 is a 9, 5 5 is a 25. Total dx square 20. Similarly, dy square. 4 4 is a 16, 9 9 is a 81, 0, 5 5 is a 25, 6 6 is a 36, 8 8 64, 5 5 25, 8 8 is a 64. Take the total dy square 311. Now multiply dx into dy. 4 into 4 16, 11 into 9 99, 3 into 0 0, 8 into 5 40, 6 into 6 36, 0 into 8 0, 3 into 5 15, 5 into 8 40. Take the total 246. Table completed. All the values we got. Now remember the formula and substitute the values. What is the formula? R is equal to summation dx dy minus summation dx into summation dy by n. That is the numerator. Denominator summation dx square minus summation dx whole square by n under root. Then again root summation dy square minus summation dy whole square by n. All these values you are having in the table. Dx dy how much? 246. Dx into dy, so minus 6 into 9. Minus 6 into 9 divided by n. N is 8. N is 8. So numerator completed. Denominator summation dx square. Dx square is 280. So I have taken 280. Minus dx whole square. How much is dx? Minus 6. So minus 6 whole square divided by 8. Here under root dy square 311. Minus dy is 9. 9 whole square by 8. Now simplify. 246. This minus into minus will become plus. Now multiply 6 into 9 divided by 8. 6 into 9 divided by 8, you will get 6.75. So 246 plus 6.75, 252.75. Denominator 280 minus 6 square. When you square the minus, minus into minus will become plus. So 6 square means 36. 36 by 8, you will get 4.5. Similarly 311 minus 9 square. 9 square means 9 into 9, 81. 81 divided by 8, you will get 10.125. So numerator 246 plus 675, 252.75. Then 280 minus 4.5, 275.5. 311 minus 10.125, 300.875 under root. So after root, we are getting 16.598 and 17.346. Multiply these two terms, you will get 287.908. So final answer is plus 0.88. This is the Karl Pearson's correlation coefficient. In this video, 3 problems I have explained, that is 4, 5 and 6. In these 3 problems, some new points we came across. Like we have removed 2 zeros and removed 1 zero. And secondly, in this problem, assumed mean are given in the problem. Here, assumed mean are not given. We have assumed. That's it. So, inshallah, the next problem will continue in the next video. So, if you are satisfied with my channel, give a like to the video, share my channel among your friends, among your groups, so that more students can watch the video and enhance the knowledge. Get a command on the subject. And do subscribe my channel. Give your comments. I have started a new channel by name Khan's Accounting Institute. Go in the search, type the name Khan's Accounting Institute. There I have uploaded the videos for IGCSE course, and it is equally benefited to all other students also. So watch that channel, that videos also. Inshallah, we'll continue the next problem in the next video.